As Director of Innovation, Dale Sinclair delivers game-changing interdisciplinary workflows, leveraging modern methods of construction and digital technologies into large-scale projects at AECOM. He's a qualified architect of 35 years and the lead author of the RIBA's Plan of Work in 2013. A whole host of publications after that, as well as the recent RIBA Plan of Work 2020 overview. He's an RIBA ambassador for collaboration and sits on the UK the Board of Construction Industry Council, which is the CIC, and was recently described as a pragmatic futurist. And today he'll be talking about the future of digital deliverables. And this considers the topic that the UK's BIM framework continues to mature and has progressed from a UK-centric PAS document, a set of PAS documents, into global ISO standards, that's ISO 19650. However, BIM continues to play into traditional design and procurement processes and workflows, and placing the emphasis on drawings rather than data. Dale will be talking about the impending next wave of innovation, which will hopefully take us beyond that. And I'll hand over to Dale.
Thank you very much, Ashley. Good evening, everyone. And just to build on what Ashley said there around the kind of ISO 19650 documents, certainly as a director of AECOM, it's great to be in an international meeting nowadays and hear some of my kind of fellow kind of colleagues from around the world kind of mentioning it. So I think that the UK has done a great job in trying to position that as not just now a UK document, but as a global document. So great to see that. And certainly what I'm doing today is designed to complement everything that 19650 does. There is nothing in here. It may sound like it at times, but there's nothing in here that's meant to kind of contradict the intent of that. But certainly what this is about is looking to, what's going to happen, for the next generation and where might we go by the end of this decade. And really, I just wanted to start with really, I guess, a structural project, which I'm sure John Leach, some of you know, has worked on this. In fact, he may have even presented this scheme. So this is a scheme that we did in Cameroon for the Africa Cup that was supposed to be held earlier this year. And of course, my team is working on this as well. And it did get me thinking when we were kind of starting to hand this over. Well, actually, since we're just doing a fairly major project, let's go back a little bit in time, possibly a bit too far back to the Colosseum, and just think, well, actually, what has actually changed since the Romans built the Colosseum? Because of course, both of these projects have got an incredible amount of innovation in them. The Colosseum, I mean, how you build that with any survey equipment or even drawings in themselves is just beyond belief. And of course, all the innovation in the concrete and so on. So lots of innovation there. And of course, in our scheme, we're using parametric design. We're working with a Turkish contractor, working with different teams across the globe. And of course, it was built very, very fast. So lots of innovation in there. But I guess when I start to think about it, the way I see it is that, over those last 2,000 years of construction, if not longer, there's only really been two paradigm shifts. The first one was really in the Middle Ages when Brunelleschi and a couple of other Florentines thought, well, actually, this master builder kind of stuff's getting a bit too heavy. Wouldn't it be nice if we just did some scale drawings and then gave the drawings to the contractor? And really that was the point. Well, first of all, we saw drawings being produced for buildings. And secondly, that disintermediation where the architectural profession split and half went on to become contractors, if you like, builders, and the other half kind of stayed in their offices, producing drawings for buildings. And of course, the buildings got more complex as they used their imagination, and engineering was born as well, I guess, as the structures became more and more complex. And the second shift is really to do with the Industrial Revolution. But what's interesting, when you look at the Industrial Revolution, it didn't actually change architecture very much. I'm sure we built a lot of factories and so on, but those factories tended to be churning out, door handles and lots of new components at a very, very low price, probably things like WCs and sanitary ware. But it wasn't really till the kind of end of the 19th century, beginning of the 20th century, when New York really started to kick off, that we saw a whole new area of new systems coming into buildings. I mean, certainly lifts were game changing because we could then go higher. The steel frame was pivotal because we could then have non-load bearing cladding. And I think that really was the second big transformation in the way that we design buildings. And of course, if you look at the history of all the professional institutes, you'll find that was really the time that they all started to, the different professions came together. So the kind of design team, in a sense, was born around that same time. So remarkable in some ways that we've only really had two. These are only, in my view, the only two major transformations that we've had in those several thousand years. I don't see CAD as being a transformation or the shift from the drawing board to CAD, because fundamentally we just replicated the drawing board. We didn't really change very much. So it's into that context that I start to look to the future and what is likely to happen. But as we all know, we've got this big, huge monster coming at us, which is regularly called Industry 4. Lots and lots of different technologies about to hit us. And of course, when I look at some of my clients, I'm designing a Murrayfield's new eye hospital just now, 300 million facility with clinical, education and research facilities. And of course, you start to think, well, how do I design the hospital of the future if the surgeon is no longer in the operating theatre? Or how do I design the education facility of the future if the educators are not actually in the room? They could be anywhere in the world. So what we find is not only are we potentially being disrupted, but our clients are being disrupted. And what I'm going to come on to is really this whole paradigm shift in the way that we design and make. So if you do kind of agree with my argument about two major changes in 2,000 years, we're about to see another two changes in the next decade, is kind of my view, and I'm going to come on to these. But of course, it gets even more complex because what COVID-19 has done this year is change a whole wealth of other things around us. So our own businesses are changing as well. So we've got our clients' business models being disrupted. We've got our own office environments and business models being disrupted. We've got the way that we travel being disrupted. And into that, we've got to take on board new ways of designing and making buildings. And just to start off, I'm not sure if any of you have seen the Gartner hype curve before. I'm a big fan of this curve because, in a sense, it kind of epitomizes the challenge for us into the future. What you can see here is lots and lots of different technologies. And I think for me, one of the challenges, certainly for us at AECOM, is trying to figure out which technologies we can really start to use in our projects today and which are the ones that may be kind of the ones that will drive how we work in the future. And the challenge with this diagram is we tend to get all these brilliant articles in the press about all these wonderful new technologies, be it flying cars or autonomous vehicles. And of course, what happens, so the way this diagram works is we all get really excited about different ideas. And then, of course, what happens is when we're getting really excited, nothing still happens. So we go into what's called here the trough of disillusionment, which is really we just get fed up reading about things with nothing happening. Now, my argument as professionals is we should be focusing our articles as they just come into the bottom of the kind of this curve at the bottom, because I think that's when technologies are about to take off. So certainly from a CIC perspective, we're looking to produce a number of digital guides next year. And the topics that we'll be looking for are exactly the ones shown at the bottom here, if not the ones that are already powering out of that curve into scaling globally and into what I would call business as usual in projects. So I think being cognizant of where these different technologies are is crucial to changing the next generation of topics. Now, there's two topics I just want to talk about to start with. Now, each of these topics in themselves would probably be a 1-hour lecture, but so I'm not going to talk about them in depth, but I do want, as part of this initial contextualizing of what we do, just mention them. And of course, the first one is all about digital twins and smart building technologies. I mean, I think next year we're going to see a lot on the Internet of Things. So we're going to see lots about sensors and so on coming into buildings. And of course, aligned to big data technologies, we will start to see, new technologies really start to drive performance improvements in building. And of course, aligned to AI, I think in 5 years' time, we're likely to see some major changes in how buildings perform. And of course, that will feed back into the design process. And of course, the UK is already on top of this. The CDDB, Centre of Digital Built Britain in Cambridge, is already doing a lot in terms of the digital twins. And there's plenty of other people looking at smart buildings and those technologies. And I do believe that those will be key to the future. And one of the reasons that they'll be key to the future is what I would say is that the contracts that we all sign up to are still, in a sense, impeding whole life innovation. But I think it's inevitable that when clients start to see the benefits of, operational savings driven by IoT technologies, that we will see in the next decade more and more on operational and capital kind of costs coming together. And I was presenting at an IoT conference in Berlin last year, and it really fascinated me that Amazon and BMW were announcing their partnership, and that partnership would yield 30% savings in their operational costs. And it absolutely amazed me that a car industry, or BMW, having adopted lean through everything that they do, was still able to leverage so much savings on a new technology. And of course, the way I saw it is, if you take 30%, well, if the operational costs are 80% of the overall cost of a building, and you take a 30% saving in that, obviously you have a 24% overall saving. So the saving in the operational phase is actually greater than the capital cost of the building itself. And I think when those sort of mathematics become clear to clients, I think it's inevitable that we will see a lot more appear on this subject. And similarly, and this is another topic which could probably take at least 2 hours to cover, the whole need to go to net zero built environment and topics such as the circular economy. And again, I'm not going to touch on these tonight, but certainly the digital tools that I'm going to talk about are certainly enablers for both of these topics, and for driving operational improvements, and also for reducing the amount of carbon that we use in our buildings. So now on to my two main themes tonight, which is around how we will change the way that we design buildings, and then, of course, the way that we will make buildings. This is, like I say, I'm working on this major project just now, and on the left-hand side, if you like, is the design team and some of the things that we're doing. And of course, we're working away in federated models. We're using a common data environment to keep everything in there. We're going through our work in progress shared folders. We're using VR actually to do coordination, which has blown me away, and some of the things that we've been able to do with that, and some of the things that we've picked up. Of course, all in line with kind of 19650 and all these standards. But I suppose my first point of frustration is what we as designers push out to the right-hand side, because what I see in the contracts, and certainly for most project managers and so on, is workflow that's pushing out to drawings. And we had a look at this, and we reckoned, well, actually, let me come back to that in a second. And of course, the second point is that the data that we deliver, I think the PAS documents 1192 did some great work getting COBE schema involved, and of course getting projects to deliver COBE and IFC files for the future use by asset management companies. But of course, that's just the tip of the iceberg in terms of data. And really, what I would say is that when you start to look at this, I certainly see that push from the 3D model into the world of 2D and EDMSs. I think we reckoned that there were 7 areas of inefficiency in there. Just the post-production aspect of creating the drawings themselves, the whole need to set up the sheet files, and so on and so forth. And then, of course, once you push it into 2D, people then kind of hold on to that as a paradigm, and then make comments back to you in 2D. And I guess from my perspective, what we're trying to do on that side of the equation is get clients into our 3D models and looking at ways that we can bring the whole team into that 3D environment. And part of the way of doing that is beginning to shift away from the general arrangement drawing as the main vehicle for communicating what we're designing. And here you can see, our client viewer that we've created for a project, where, what we discovered with some of the tools that we were using is we were finding it really hard to basically expose the data that was in our models. So here you see an operating theater where we've been able to work with Autodesk using the Forge platform to really reveal all that data. And of course, once we have a library of this type of space globally, we can begin to assemble hundreds of different spaces in different ways. And of course, we can change all the equipment in these spaces. So we're able to work in a completely different way to the traditional general arrangement drawing. And we certainly see the future being around digital libraries of spaces such as this, which have all the MEP, possibly the structure if it's an offsite manufactured space. And a whole wealth of data that we can make available to the client. So this is sort of tool that we see, clients having at handover. Now, what you won't see here, because I don't have the slide in, is that the client can navigate from an individual floor of the building or department to a single space and up and down using tools like Power BI and a few other ones that we're using. But the whole key thing here is about moving to that 3D environment, commenting in that 3D environment. And then what we discovered is once we got all these kind of spaces, we filled them full of data, including all the room data sheets. Now, we could use that data in different ways. So on the right-hand side, again, you'll see a Forge kind of tool that we've developed where you can actually start to, separate the model or the space itself and see all its constituent parts. So, we can start to look at bills of materials. We can see all the different components that are in there. And then, of course, all the other data sources from the equipment list to the specification, using other tools like Autodesk's Assemble to clean up all the data, Invocara to do all the classification, and of course, all the VR-ready spaces that we're doing itself. So everything is really about powering up the data into that 3D environment. Now, what I do see is some of our colleagues do talk about it's not about the geometry anymore. And no, that's something that profoundly as an architect, and I'm sure you as structural engineers would agree, that I disagree with. I think the future will always be driven by geometry. I think it's just perhaps fair to say that, if we're looking at scripting for, doing parametric geometry, that geometry is still king. But I think there's a huge amount of value to be done by looking at a whole other wealth of data sources on projects, and of course by trying to connect that data into other software tools, for example, that the structural engineer is using, so we can look at how we automate things. But the key thing here is keeping it all 3D, exposing the data and working in a different way. And the next kind of level of development that we've been working on is what we call digital libraries. The single project process is incredibly inefficient. And by working in digital libraries, which we've created for a number of clients, what we're able to do is to take whole parts of the building and put them into a library that can then be used at stage 2 of a project. So in essence, that when we're in stage 2, we're actually using stage 4 content to help to build our models, speeding up both stage 3 and stage 4. And of course, all this content is reusable and customizable. So a lot of people say, well, this is about commoditization of architecture. That's certainly not the intention. This is just about having much better information and then being able to quickly adapt and reuse that on other projects. And certainly, what was really interesting at the beginning of this year is we were seeing lots of articles about people getting excited about this decade ahead. And we were already starting to speak to clients saying, well, we don't think the commissioning pattern of buildings will be the same in 10 years' time. We can't see clients commissioning an individual building. They'll commission programs of buildings. So because for things like net zero, to take place, I don't think clients can afford to have, for example, on 10 projects, 10 different teams taking a different view on what science may be appropriate for them as a client. So I think increasingly throughout this decade, we're going to see the production of digital libraries that work at a multiple project level, a program level, and then the honing of those libraries onto the individual project to suit the needs of a specific site or specific planning conditions. And again, making the whole process much faster and more efficient. And then when we come to the other side of the equation, so if you like, that's the client side of the equation, the design team part of the equation. Yes, of course, we've been doing parametric modeling for ages, and certainly some of you may have been at the Autodesk conference a few weeks ago, and generative was mentioned at least once or twice, and I think that looks like it's going to be the hot topic of 2021. But what I would say about a lot of the digital tools that we use is that we're still sitting them alongside traditional ways of designing. And one of the reasons that we're not getting efficiencies that BIM might deliver is because of that. So we're still doing our sketches, we're still working through stages 2, 3, and 4 in the same kind of way, building up from scratch. And as you can imagine, if you're starting to use a digital library, then instantly you have a much higher level of detail at stage 2 and can work much quicker through the process. And I think there is another problem with making decisions intuitively. And of course, at stage 2, the RIB plan of work says that stage 2 is more about rules of thumb and intuition than it is about calculations. But of course, the challenge with that is the rules of thumb still cause iterations when you go to the next stage because you're obviously not precise. And certainly what I see is with the number of topics that are driving change just now is into the future I suppose what things like climate change and social value or D4MA are doing is changing the whole knowledge base that we have. We're having to, in a sense, reset our knowledge base for doing the lead designer role. And so, simply, the knowledge that I've had building buildings for 35 years becomes less relevant when so many things are changing. And I think that's the context that we've got to look at changing how we design. And one of the things that we've done is started to look at what we call mini models. So taking pieces of the building and building them in a much higher level of detail. And of course, this has been using a tool called Inventor. So we're actually using the tools of the manufacturer now rather than the tools of the constructor. And what we do is we develop mini models which we can then, at the beginning of stage 2, instantly get right. So they're parametric to work with the building floor to floor heights, the occupancy of the building. But we can also start to look at different balustrading systems. So at the beginning of stage 2, we can quickly take these pieces of the building, hone them to the client's requirements, hone them to the emerging general arrangement drawing, and then start to lock down fairly major pieces of the building. And the key thing there was what we realized was that to design a staircase needs 150 individual decisions. So already we were trying to cut those decisions down to effectively 0, albeit that some clients want to make more changes than others. And of course, the other thing we're able to do is that because we've now taken all of these decisions away, it does buy us some time to start to look at other things, like how do we get balustrading systems to be geared more to design for manufacture and off-site manufacturing. And a lot of our mini models now, we've actually got a lot of the in situ connections between the precast stairs and the in situ walls. So we're actually taking this whole concept to a new level of kind of buildability and health and safety. And again, all at stage 2. And then, of course, what that also allows us to do is, as we start to change the design process, is look at things like configurators. So as an architect, if I'm doing a commercial office building and I want to have an off-site manufactured toilet, there is not a single website in the world that I can go to configure that. I can do that for a car, but I cannot do that for an office building. So what this concept, proof of concept here, is saying, well, here's a pre-engineered toilet. So I've got all the structure in here. I've got all the hot and cold water. I've got the mechanical systems. And I can go into this with my client and I can configure the taps, the sinks, the ceiling finishes, the wall finishes, and even look at cost as I go through it. And at the end of this process with the client, I can then bank this. I have costs because I'm obviously now working with a product, not a piece of design intent that the QS then needs to go to a company for them to guess how much it is. I'm able to work with products. And for me, this is a big challenge for the future, that we simply don't have enough products available in the marketplace. We need to start looking at products like this that we can specify rather than designing using design intent and then have a contractor design them. And of course, I spoke recently about the RIB plan of work. And of course, some people will say, well, what does this mean in terms of the different stages? I don't think it will change the stages at all. But I think the trends that I would say into the future that we'll see is certainly if we're working with digital libraries, we'll have to start with those. So we'll already be able to start with spaces that are taken to RIB stage 4. I certainly see to a certain extent the convergence of stages 2 and 3. Because obviously, if we've got connected data, then you as engineers can start to much earlier bring proper calculation to bear rather than rules of thumb. So I would certainly see stage 3 being much quicker in the future on the basis that we can leverage some automation of those calculations at stage 2. And then at stage 4, of course, I think that will be no different in many ways. It's about pushing out the optimum information for manufacturing, which will increasingly be the case, but also construction. But of course, I'm going to come on to that in a minute. And the 3 rules for me, for the future for design are about, to me, this whole thing about trying to get digital libraries and so on is not about commoditization. We need millions of parts and the ability to make buildings the same way that we do in lots of respects. No, every building still wants to be unique. I don't think our built environment would be too attractive if we had, say, half a dozen options for facades or whatever it might be. So it's about that flexibility of design, but at the same time teeing up all those models and so on for automation downstream so that we can start to automate out into stage 4 and into manufacturing production. And of course, the third piece of the jigsaw is making sure that we're not creating any barriers to SMEs or to any product suppliers, so that we're able to create the future so that everyone can continue to contribute into it. So that's my kind of initial ideas on our thoughts. Well, when I say ideas, these are things that we're doing in live projects at this point in time. And in terms of making, I just constantly refer to this kind of slide from the Oxford University. This is quite an old one actually. It's probably 6 or 7 years old, looking at the possibility of automation in the construction industry. The way this works is basically the top left is the professions that are most resilient to computerization, and bottom right are the ones that are given that they're going to disappear. Blue's the design team, yellow's the construction team. And what you can see here is that pretty much most aspects of construction are ripe for automation. So whether that's in a factory or whether that's cranes that come to site, we are likely to see some significant changes in the future as robots start to scale and of course become affordable to the contractors on site. And of course maybe kind of labor scarcity driven by shortages of European workers and things like that may actually be the catalyst for us using more robotics into the future. And of course the action just now is all around volumetric. Just about every residential scheme is considered, if not doing, is certainly considering volumetric. But of course, the supply chain is not currently geared up to deal with the number of clients that actually want to use volumetric. And of course, a lot of my clients say, well, Dale, it seems to me that this is just like construction under the roof. And so I think there are a couple of issues that we do need to tackle here. But from a design team perspective, we certainly see us at stage 4 delivering what I would call stage 1 fabrication drawings in the future. And on the right hand side here, you can see the sort of thing that I'm talking about, that we actually deliver using Inventor models to fabricators that are ready to go into the second phase of fabrication. So it's not like design intent where the fabricator has to take our model, rebuild his own model. I think we're going to see greater convergence between us as designers and manufacturers, and I'm just going to come back to that topic in a second. And of course, the other thing with D4MA is, in all this kind of fuzz about the residential, we forget that hotels have been doing volumetric for at least 10 years, been doing it for some time, and they quietly continue to do so. But of course, at the other end of scale, for some of the bigger buildings that we do, aircraft, hangars, airports themselves, possibly even offices where we've got long spans to get open plan offices, cannot use, volumetric. But there are, of course, other D4MA possibilities there around, sub-assemblies and so on. So I think we just got to be cognizant when we're thinking about design for manufacture that it's not just about volumetric, it's about lots of other new technologies as well. And again, I'll come back to that in a second. And I think the other thing that we forget when we say, well, we need to go volumetric as soon as possible is that, again, if you go back to that image of the Colosseum, is the construction industry last year sold something like £7 billion of materials. So there's £7 billion of construction materials that are made for the human hand. So whether that's bricks or sheets of gypsum or screed that is going to be laid, these are all materials that are geared to construction. And I think just saying let's move to off-site manufacturing is in itself not enough. We really need a national strategy to look at how we transition from this huge industry, with builders, merchants, and all the other companies that are aligned to this. I mean, these companies are not going to disappear overnight, and they're going to continue to try and do what I would call optimized traditional to keep us into traditional construction, just because of the sheer weight of the industry that's behind that. And as part of that optimized traditional, of course, we'll start to see some, automation, people taking some of the health and safety factors out of the equation, so making it safer for the human, or taking out the human out of the more dangerous environments altogether. And, what's interesting about this video is that the reason I get concerned about this is the first time you see robots doing construction like this, you get really excited. You say, wow, look at this bricklaying robot. Isn't this fantastic? Maybe less so for the robot on the left, who looks a bit kind of cheesy. But the key thing, the reason this concerns me is what we're really doing here is we're taking a robot and we're replicating what the human does. And I think, again, as designers, I think it should be incumbent on us to actually take a step back and say, hold on a minute here. This piece of clay, which has been around for 2,000 years, or if not more, the brick was made for the human hand. What would a brick look like for a robot? Would it be bigger? Would it be thinner? Would it be taller? How could we reduce its carbon footprint? And similarly, what would a piece of gypsum look like for, a robot that might install it on site? It might actually be smaller, because a robot can install smaller pieces much, much quicker. So I think we need to get away from this kind of robot doing what the human did and think more profoundly about how we use robots into the future. And of course, how do we issue information to those robots? Because I'm sure that the robot will not want the same information that the human currently has. And of course, the other thing is that in a lot of industries have already got to the phase where they're doing 24/7 manufacturing, or lights out manufacturing, as it's called, where everything is made in factories by robots. And I think we're a long way off with that in the construction industry, but we're not going to see incredible production productivity improvements until we start to see greater use of robots off-site, and I guess arguably on-site as well. And back to this point about my stage 1 fabrication drawings. So certainly a lot of my clients, when I'm showing them some of the stuff they're doing, they're saying, well, yes, so you're working with suppliers on, design or manufacture-ready models and information, but then I'm going to be tied to that contractor, so they're going to push up their prices. So the key thing for me always is, even if we're working with tools like Inventor that are kind of facing the manufacturer, we still need that supplier resilience. We still need that model to face a number of suppliers. And I think that's kind of taken as a given moving into the future. And then last kind of couple of slides on this topic. And the other thing we certainly believe is that, we've been showing these slides for a couple of years now, is that the future is not about a shift to manufacturing. It's about convergence of manufacturing and construction. So certainly what my team are doing just now, we're looking at how to optimize construction information, how to get that instance data. So we talk about object modeling, which I think is important as it plugs into digital libraries. But of course, many of the things I do, whether it's the carpet finishes, they are objects, but they do need that instance data. And of course, how do we get the contractor into a 3D world? How do we stop issuing stuff in 2D? And what is that next generation construction information look like? And of course, on the other side of the equation, we need to look at things like bills of materials. So we've been starting to push out bills of materials instead of bills of quantities. We're looking at configurators that I've already mentioned. We're looking at pushing straight from stage 4 into manufacturing information. And we're looking at things like PLM. So we're kind of shifting our language into that of the manufacturer, whilst at the same time optimizing our construction information. And just going back to that example, so, as an architect, I'm used to, for a partition package, which is one of the more complex ones that I need to do in a building, is I would traditionally be issuing a set of 1 to 100 wall types and a set of 1 to 5 details. But again, what I would say was, how do I stop that 1 to 100, that scaled paradigm? Can I not do a viewer where the contractor can see any piece of my wall information on the fly in 2D or 3D? And of course, the example you can see here, we've been using Inventor as part of our mini model process to take kind of drywall detailing to the next level. So we've got every single stud shown, so we can actually give the contractor quantities, bills of materials for every single piece of that core. And then we can start to look at micro 4D. We can start to look at how to optimize the buildability of that core. We could even look at scheduling how the different pieces of that core go into different pallets to assist with the logistics. So thinking about a whole new generation of construction information. And of course, the final piece of that jigsaw is we've already been speaking to some robotic companies. So we're seeing now robots such as the one you can see here, actually setting out partitions on site. So instead of issuing my 1 to 100 information, I need to issue some code to this robot who can then set things out on site for us. So a completely new generation of construction information. And this is what we're trying to think about in the future. What does good look like? What does the contractor need? And how can we then take the next step of this journey in terms of pushing even straight into the machinery? How can we push when we issue our construction information? We want to be making things tomorrow. So that kind of validation of what we do straight into manufacturing is crucial. And here you can see the sort of thing that I'm talking about, this 4D model. You can see how we're kind of rehearsing how the different pieces of this core and office build and this kind of hospital come together, the precast stairs, the balustrading. And because we've got this to an incredibly high level of detail, we're able to go into VR once we've built this and actually walk around and look at every single junction and find the smallest of kind of niggles in the things that we've been doing. So I do think in terms of, moving, certainly the parts list that you see for the car here is a very pure parts list. I don't think buildings have the same type of parts, but I think we do need to look at what those parts lists might look at like in the future and what information that we might issue. And the 3 stages I see coming into the future is really, the first one is about optimizing traditional construction. I think that's taken as a given. And of course, the incumbents in traditional construction manufacturers and suppliers are having to do that just to keep innovation at bay and try and prevent this paradigm shift that I talk about. I think the next thing that we'll start to see is, and this is where I think as designers we have a lot to do, is Industry 4 needs a whole new generation of products that can be made in a factory and then installed on site by a robot. So we need to think through what are those products. They don't exist just now. So what might those be? Because until we can get the supply chain to start to make them, we need to actually tell people what are the things that we would use if they were available to be made in a factory. And I think the hardest thing of all, of course, is moving to new materials into kind of on-site methodologies that, will need a whole new generation of kind of standards. So, for example, I've said to BRE before, well, if Elon Musk can print a rocket using 3D technologies, surely we can print a building. But of course, the answer to that is more complex than you might imagine, because aerospace companies are used to making things, they're used to metallurgy, they're used to making things in clean room environments. And of course, we're trying to bring a 3D printer to site, just brings a whole generation of questions around, how do we know the mix has been validated? How do we know it was the right temperature, and so on and so forth? How often do we need to calibrate the printer heads? And I think it will be the same for any new material. So I think it will be a while before we see some of these coming to fruition. And certainly a lot of the additive manufacturing stuff that you see around concrete is not what I think will certainly come to bear in the buildings I'm designing. I think it's more some of the newer plastic or metal printers that we're likely to do some work with. So my final kind of slide here just is really about, from that data side into the future, we're going to see, data moving beyond COBE into the data required for a whole new generation of smart building and digital twin technologies that are going to suck all this data from sensors in our buildings and really drive the whole life proposition. We're going to see the connected data, really making stages 2 much faster as we can do real-time iterations of the design. So for example, if I'm doing some options for a facade, if I've got a dashboard that tells me carbon, cost, daylighting criteria, and a whole wealth of other tools, I can much quicker look at options without then having to push those out to the engineers and then wait for that kind of feedback loop to happen. I can do it in that kind of real time. And then the final piece, of course, is trying to bring all the product manufacturers into this and trying to get way more data than we currently do through, the National BIM Library, data that can actually help us make those kind of analysis or better comparative or better comparisons of different products in that kind of real-time environment, whether it's cost and so on. So anyway, I think that is that's my slide deck finished, and I'm more than happy to take some questions. And hopefully you've got some good ones lined up for me.
Thank you very much, Dale. It's very interesting. It's Industry 4.0 is I feel probably more of a burden on the construction industry than many of the other manufacturing industries who have had things like robotic construction for quite some time now. So, but of course, what we do is always custom made, and then no two buildings are the same. I'd like to ask a question if that's all right first.
Of course,
Now you mentioned the other industries, for example, the automotive industry and the aerospace industry. They tend to sort of be the designers, manufacturers, and sort of suppliers of their own products almost. I mean, of course, there are supply chains, but generally speaking, these things are, of course, made in factories and such. Now, there's a trend to bring professions, including the architect, the engineers, fabricators, contractors, earlier and earlier into the process of design. So where's the limit of that? Is it going to result in sort of an incumbent design team that's fully formed from day one and employed in the DFMA sort of design for manufacturer assembly, and sort of how does that encourage any sort of cost saving or similar in the built environment if you've just got the same team running again and again and again?
Yeah, well, certainly from the work that I'm doing with my team, I'm fortunate enough to obviously be in a multidisciplinary practice, and I certainly can't do the innovation that I do without having the full design team around me. So I certainly see, even today I was on a call about a project that, it's only a £20 million project, and the client is putting out the different disciplines individually. I think in the future it's inevitable that clients will commission a single design team. Now, not necessarily a multidisciplinary practice, but allow the architect to work with the engineers that he's used to innovating with, because there's no way that you can get some of that connected data and some of the workflow that will be game changing in 4 or 5 years' time without working with the same practices time and time again. So I think that would be my first trend as we see greater efficiency of multidisciplinary working. And of course, the reason clients still commission separately is because they haven't seen the efficiency gains of that multidisciplinary working. But I think it's inevitable now with the ability of using data that will come in the next 2 or 3 years. So that's the first point. The second point, in terms of what the government's doing, I mean, the government's still hanging its hat on contractor-led procurement for sure. But if you go to the private sector still likes to novate its design team to the contractor. The way I see it, if you look at how I might work through from my digital library, really efficiently through a project. The procurement is actually the biggest challenge because I've got my digital library. I've got a lot of information there. I can use things like configurators, so I can work my design much faster. I can automatically push out to the fabricators. I can push my information, sort of making things tomorrow. So I can see that end-to-end efficiency. And procurement is still, it's back to my optimizing traditional. Procurement is still being played to optimize traditional. And I don't think we've really come up with a methodology yet to figure out how to get that whole chain going through. I think the contracting side is changing so much as well because obviously it's turning into more of a logistics kind of aspect, consolidation centers and so on and so forth. So I think contracting will inevitably change. And I suppose some of the models that you can see, the clues of the future are the housing companies that are really doing full integration. So, Urban Splash, Legal in General, and a few others where they're basically building their own factories, doing their own designs, and taking control of the whole process. So I think we might see some of that. We've seen some of the bigger commercial clients start to look at the platform approach. So some of the work that's been done there and making building frames more efficient, but still, of course, pushing into the contractor approach. So I don't think actually there's a specific model that's rising to the top of the pack just now. I think that the current models are not going to work in 5 years' time because things are going to be so different. And I would like to think that eventually people will start to say, well, given a program approach, should we be that now start to take that program approach to how we commission a serious project? So I think the first move might be clients might commission an integrated team on a number of projects and then try and keep rolling that success. But of course, the key to all of that is they have to see the metrics improve. Cost has to come down, delivery has to be faster, because without these, traditional design doesn't change.
Yeah, that's a very good point, and it takes some brave souls to make the initial leap in order to actually put a lot of these techniques and these new sort of contractual paradigms into practice. There is a question actually that leads on quite nicely from David C, where he is asking if fabricators are going to fabricate straight from a designer's model, are, for example, AECOM or some of the other big firms okay to take the contractual responsibility for the accuracy and suitability of that models, and sort of what new skill set is required to achieve this? I think it leads on quite nicely from the previous question in the sense that who takes on the sort of liability and the risk for this?
Yeah, well, AECOM is doing that. We have our own modular product, and we're doing the fabrication drawings for that. There's no one else involved. It's the same team that we traditionally have done stage 4 information that is now doing the fabrication drawings, and we're modeling every single screw. So we're taking our models to incredibly high level of detail, and certainly that's where my team are kind of going into the future. Is that product? I'm really keen to start doing more work with suppliers and looking at integrated teams and producing that fabrication level information. I think for too long let's face it, one of the reasons the construction industry is not getting productivity improvements is because our information is just not good enough. So I find it quite exciting being able to get my information to such a granular level that I've actually got greater confidence in it, because I can actually go in and I can see every single junction and screw. And I think that's one of the benefits for me about being in 3D. Is for me, if you're relying on 2D information, you just don't have that confidence that the details are 100% working at the corners or at junctions and so on. And I think working fully in 3D, I think it takes a lot of that risk away from me, even although we are, in a sense, taking on more liabilities.
There's, I suppose, in a sense, you've got greater control over the sort of the finer detail, in the sense that it's not limited by resolution on a drawing. It's sort of interactive. Another actually very very good follow-on question from that actually. There's from Aaron Aaron T. Is this automation and digitization of future construction and the sort of integration of design teams, presumably. Does that mean loss of jobs in the construction industry? And what are you finding at AECOM with integrated design teams? Are you having to hire less people, for example?
I don't. No, I don't think we are. I don't think there will be loss of jobs. I think the jobs might redistribute themselves because I mean. I think there'll be more science involved because remember to get to kind of net zero kind of environment. I think we will spend more time looking at coding and scripting, so to that kind of optimization of how we do workflow. So I can see utilization coming down as projects get more efficient, and then more team members actually being sitting at things at a program level. I think we'll see, if the cost comes down and the value of what we do is appreciated more, I think we will see arguably designers being used on projects more. Sometimes, architects are not used. Clients just go down straight to a manufacturer or whatever they might do. So, and I think that, I think it's just really the shape of the design team will be different in the future. I think we'll see new professions coming in because obviously we need data scientists and I think personally it's really exciting because, it'll become more about manufacturing and data science and how do we get down to net zero. So I think the topics that we'll be looking at will be incredibly exciting, and I love to think that in 5 years' time it will be a much more attractive industry for people to come into. And so yeah, personally I'm really excited about the future.
I think that's a really interesting point actually. Sort of the increase in diversity of different professions coming into the construction design team that previously didn't perhaps sort of weren't able to find their niche within our industry. And actually, these questions are leading on extremely well from each other. A question from Will H is, Dale, what's your view on how prepared academia is to support current and future innovation in construction and delivery of digital delivery of projects? The current curriculum has changed minimally in the last 30 years from school leaver through to university delivered courses. And of course, this ties in perfectly with the idea that the construction design and delivery team are going to become increasingly diverse. How can academia support that?
Yeah, no, I think that's a really good point. I think education has to adapt at some point in time, but it's not something I kind of think about too much. I mean, I think we are about to enter the era of whole life learning. So I think that will be the big difference, that we'll need to keep continuing to learn brand new skills. And I mean, I can guarantee you what I've showed you tonight. If I was asked to do this presentation in 4 months' time, it would be completely different because things are just moving that fast just now. And I think the challenge for the future is how do we? It's not just about students coming out from college. It's how do we kind of reinvent the design team for the sort of things that I'm talking about to get those right. That new, more diverse balance of skills. And then how do we keep retraining people when things are just happening so fast? So I think that's a bigger challenge, because I think the younger generation are kind of, a lot of the younger generation are coming, up with good knowledge of, using tech, gaming. They're able to use gaming tools. They're able to code. They're able to script. But of course, we're now moving already to a no-code future. So I think for me, I think creativity will become center stage, because, I think more of the things that can be codified will be codified. So I think that's going to be one of the main differences.
Well, I think it's an interesting question, and I'm sure there are a lot of graduates and sort of young engineers or similar on the webinar today. Out of interest, what's your view on whether, for example, should computer scientists, data scientists, and such become construction experts, or should construction experts become data scientists and such?
I think a blend of both is probably a good thing, because I certainly do get concerned sometimes when I see people that don't really understand the science or the art of designing a building coming in and trying to reinvent what we do. I think there is value in that to a certain extent, but I think for me the biggest innovation comes from people that are digitally savvy but actually understand intimately how the different professions work within the construction industry. I think it's quite hard to, I know some of the lean thinking kind of publications and so on would perhaps say opposite, but I think when you're trying to move to that paradigm shift, I think it comes best from those that really understand the nitty-gritty of what we do, but whose minds are open enough to really start to look at new ways of doing things. And certainly that I see that so many people, I think that's one of the challenges of level 2 BIM, is people, let's say people are doing these fantastic models and then just producing the models to do a set of drawings, instead of saying, whoa, let's stop. Why are we still doing these drawings? What this is crazy. Why do we want drawings? No one needs drawings in the future.
It seems like 2D drawings with just more steps, effectively.
Yeah, well, exactly. So I think, and certainly that was my experience way back when we went from the drawing board to CAD. A lot of people were nervous about the change, and therefore I think it kind of it impeded innovation, and that's certainly my view now, that trying to keep drawings as the focal point contractually is certainly impeding innovation and greater kind of integration of more data kind of solutions.
I think that's an interesting point you just made, actually, with regards to the hesitancy to sort of trust new technologies and new ways of working. We've got a question from David B about big data being useful, but what about sort of data analysis? And to a certain extent, that sort of follows on from this, and it's a case of perhaps extend on David's question. It says big data is useful, but what about data analysis? Decisions have to be based on the analysis. What developments are in analysis or available, and how do you think that this squares with other industries, which perhaps the aerospace industry, the mechanical engineering industry, which can prototype structures that they build, they can test them, but we can't in the construction industry.
Yeah. So I think going back to the big data one, first of all, I don't think big data really comes to play in the design stage, other than we maybe can get huge data sets from buildings in use. So for example, if I've got sensors in a building and I can start to really get some really granular data about how those spaces are performing, maybe that helps the performance gap because I'm getting actual data. And certainly what I see is a lot of the simulation kind of software is probably still not accurate enough to use, other than what I would call quick and dirty. But what I would say is, if you think about RIB Stage 2, that arguably, again, if you look at the 2020 plan of work, it talks about rules of thumb. I think you can go beyond rules of thumb, and certainly as an architect, having even a piece of analysis software that allows me to, like I said before, like work up a facade system and get that real-time feedback on, U values, daylight, cost. I think that would be game-changing for architects to get that analysis in a real-time configuration, and I think that's inevitable. I mean, the challenge that we have just now is things like CFD analysis. It just takes too long to get that information back, by which time the design has moved on. So I certainly see that kind of real-time analysis being the game changer in, I don't know, say 5 years' time. That's maybe when we'll get more. But of course, the thing is, as construction professionals, we can't afford to make any mistakes. I think that's a big difference between us and some of the other software companies. Obviously, some of the entrepreneurs talk about, well, let's get our software what's it, go fast and break things kind of things. Well, of course we can't break things. We've got to get everything 100% correct. So I think, trying to get those checks and balances to make things happen faster, but then having that overlay, and certainly in the short term, I think the quick and dirty tools will be used at the front end, which makes it more accurate, the rules of thumb. But then eventually we'll see simulation from real-time sensors and so on, improving all our simulation software, and then AI will start to really start to make that even better and better.
Right. So effectively, in answer to sort of David B's question, is a case of the data collection side of things will be used to iteratively improve the capability of the simulation software, which we then use to push forward in terms of design.
We use the sensors in the building to get that, make the simulation even better, because then, that's what digital twins have been doing in aerospace for years, given Rolls-Royce and so on, that feedback. This is how we simulated the engine was going to perform, and this is how it's actually performing. So I think that kind of simulation will be crucial to that feedback loop in the future. And going back to aerospace industry, one of my friends works for Boeing in Seattle, and I don't think the way they design wings is any different. They've been outsourcing stuff recently to France and Russia, and they've got global supply chains. But the big difference is they spend a long time designing one aircraft, and then they build lots of mock-ups. But essentially, a plane is a product. It's not a one-off. It's a product that then gets fitted out to suit the needs of different airlines. But the actual shell and core of the plane, if you like, remains the same. I can see that in some senses in the future, but I think that's where we should get worried as designers. If we start to commoditize buildings, I think our built environment would be pretty horrific if every building kind of came from the same kind of cookie cutter. So I'm more interested in mass customization and those sort of processes than I am
mass customization, mass bespoke and such.
The things where we can still create that higher level of detail, much better information, use different tools to make design decisions like configurators, but then still go really quickly through the process.
Absolutely, it's a tough one, but of course, as you say, the commoditization of buildings would lead to a very boring and perhaps a little bit grey skyline, I imagine. There's a question here from Ricky. On a number of occasions, we, the company he works for, have discovered the use of library items in a model may have been included to allow for example, sort of approximate space or approximate section sizes and such. It mentions that unfortunately clients seem to take these as sort of truth almost. So they assume that these elements, especially the sort of structural elements, have been fully designed and specified. So what sort of quality checks and sort of validation of the models that you put out? What sort of validation occurs? This is more of a specific question for your workflow, I suppose.
Yeah, well, I think again back to going things. There's lots of tools out there now that we can use to validate what we're doing, and I think that there's been a lot this year about algorithms that go rogue and all that sort of stuff. With exam results, but listen, look at the end of the day, an algorithm is just a set of instructions that get followed, and I certainly think we'll see more of them in the future. And there's so much about what we do as designers that is basically that can be kind of automated because you can turn it into a set of rules. And I suppose my view on that is that, you see people talking about using things like Celebri or whatever it might be for validation, but my view is if you can set some rules to validate that a model is compliant with whatever rules those might be, you can then set up the rules to automate the production of the model in the first place. So So, and this is back to my point. I think the more that we can figure out how all the different bits of what we do come together, I think the more automation that we'll see. But I think the automation will really be driven from the back end of the design process. No, I can't see a future where, we want to rip away all of the time for that front end optioneering and that creativity and the idea that might make the building different. So certainly I see stage 3 being much faster because hopefully we've used some simulation tools in stage 2 that have made stage 2 actually more accurate. And as those become more accurate, I think I would see that in 10, 20 years' time, I mean, it may just be that stage 3 gets subsumed into stage 2 because a lot of the engineering analysis becomes kind of automated into the architect's model and into the digital library and all the bits that they're using. And then we then automate straight out of stage 3 into stage 4. So, but I still think stage 2 is going to remain robust into the future.
I think it's a common theme with quite a lot of these lectures that we're putting on at the institution, in the sense that it's the idea is to free the engineer or the architect to make more creative decisions rather than effectively the grunt work. They automate the boring stuff, as they say, almost.
Exactly, and I think that goes back to the point why I find that the future incredibly exciting, and why I don't think there necessarily will be job losses, because all we're doing is taking the drudgery out of the whole process and making the things that are exciting, the things that we do all the time. I think the one thing I have said in the past is, is my only concern with that is if we take away all the easy bits, then what do we do on the days where we're not feeling 100% for whatever reason? If we take away the easy bits, it's only the hard bits that are left. And I suppose the question is, well, can we actually concentrate for 40 hours a week on only the hard stuff? So I suppose that's a question mark in that one. Maybe that points to different ways of working in the future. But you know what I'm saying? I don't think you can do 40 hours of the hardest work that you've ever done every single week in, week out. So I think the work patterns do need to change. But of course, we're seeing a lot of that conversation happening anyway this year.
It definitely seems that way. On the plus side, it enables us to reach a wider audience with these evening lectures, which is quite nice.
That's true, yeah.
We've got a question from Tony again, sort of going back to sort of more the broad view of the industry. He's asking if, given the current landlord-tenant model, for many building types, the party specifying and procuring the building has little incentive to focus on whole life costs or similar whole life carbon and such as well. How do you see this changing to get away from the current focus on capital costs and looking more holistically at the overall construction project?
Yeah, no, I think he's absolutely correct. I think that is a huge blocker just now. What I would say is, even when we work with a client that has ownership of the capital and operational costs, it can be tough because different departments own the different budgets. So just someone owning the whole thing doesn't necessarily make it easier. I think all I can say is just what I said at the start. I think when people start to see the savings that get yielded from IoT and digital twins, I think we'll start to see more convergence of that. And certainly, I get what you're saying about the developer trying to make the building as cheap as possible, if you like. But at the end of the day, developers need to sell their buildings to tenants, and tenants will get more demanding in the future, and so the developers are always reevaluating what they need to do to get the tenants in, and maybe if less of us are going to be going into the office in the future, that competition will get even fiercer. And of course, if we're trying to make our buildings more flexible and adaptive and so on, I mean, some clients might be willing to pay more to have that greater adaptability so that they can, sweat the amount of space that they rent even harder. So it doesn't concern me in the long term, that. And of course, planning regulations, I think, will change. The London plan's just kicking in, and it's got some really onerous kind of carbon and other circular economy and so on kind of requirements. So I think a mixture of tenant demand and regulatory environment changing will hopefully keep that one in check.
It definitely seems that tenant demand patterns are going to be changing if the sort of current climate environment in terms of the COVID crisis continues to bite, or future similar pandemics will bite in the same way. Perhaps there's a model for sort of short-term let, in which case there are going to be firms which are designing and building all in one. But as you say, perhaps that doesn't necessarily translate into reduction in operational costs over capital costs.
Yeah.
We've got a question from Peter. Again, I think it's more sort of broad, sort of industry wide. If Peter says, if one imagines a mature industry of multiple design teams and manufacturers using configurator tools, would a single configurator serve them all? Who would develop this? Otherwise, if each design team was to develop their own software platform, every supplier would have to interface with multiple configurators. I think this echoes a very similar problem we have in the construction industry with software interoperability generally. So I suppose that this links into software interoperability.
Yeah. So I mean, so certainly the configurators we're looking at are sitting on the manufacturing side of the. I mean, we're my team anyway. We're 100% in the Autodesk suite, and certainly my preference is to work wholly with Autodesk tools, because then I don't get sucked into that interoperability issue. And on the manufacturing side, there's things like Inventor and Fusion and the iLogic that are all part of that kind of ability to configure products. So what I see is some of those, the Autodesk have been releasing a lot of APIs and that can be used with Forge to start building on all of these kind of different tools that they have. So certainly I see within that suite of documents us being able to do configurators. And the car industry is, I mean, I guess they use SolidWorks maybe more than tools like Inventor, but again, similar configurators. They're all fairly standard nowadays.
I think sorry, go ahead.
Yeah, just one thing I would say about configurators is I think there's an element of the art of the sale, let's say, in configurators, because when car manufacturers talk about configuration, I'm sure, like, pick any car manufacturer, they'll say, yes, we have 25,000 options for our cars, but actually when you drill into it, that's just nonsense, because there's very little that you're configuring. You maybe can choose the suspension, leather seats or fabric seats, the color of the paintwork. And it's only that the theoretical variations are a lot, but in reality, there's not really much that you can configure. It's not as if you can re-engineer the engine or so on. And I think that's a lesson that we should be taking into construction. We shouldn't be inventing everything, from scratch. Back to my stair analogy. Why do we start from scratch on a stair every single time, and then, lots of time we don't get it right, bizarrely?